I'd like to now talk about balancing redox reactions. Now what we already know is that oxidation is defined by loss of electrons and reduction is defined by gain of electrons. So we can use this to take reactions under which redox conditions are occurring, and we can find their oxidation and reduction reactions, and then we can use those to actually balance the reaction. So we're going to split it into two half reactions, one oxidation and one reduction. This is a summary of the method we're going to use, and I'm going to show you this in terms of an example. Alright, so here's our reaction. Mn2 plus Cr2O7 minus gives MnO2 plus Cr3 plus. So the first thing we need to do is split it into half reactions. Well, what we need to realize here is that it's actually elements that are being oxidized and reduced, so we're just looking for the things that have like elements associated with them. So Mn2 plus goes to MnO2 will be one half reaction. And our other half reaction will be Cr2O7 2 minus gives Cr3 plus. So I took everything that involved manganese, that became one half reaction. Everything involved chromium, that became my other half reaction. The next thing I need to do is balance the elements that are actually involved in the redox process. Now to do that, we need to first of all be aware of how to discern how many we have and what the charges are. Now the charges will always be up the top, so you'll always see the charges here. Down here you'll see how many of an element you have, and the 4 here would refer, for example, to this oxygen right here. This would be 1 manganese and 4 oxygens. Alright, so don't get mixed up between the charges and how many elements you have. Alright, so we go over here, we've got Mn2 plus, that means there's 1 manganese, and then down here in MnO2 there's 1 manganese, so that one's balanced. Now down here we've got 2 chromiums and only 1 chromium over here, so I'm going to have to balance out the chromiums first, and that means I'm going to need to put a 2 in front of the Cr3 plus. Alright, so now that's step 2 handled. Next we need to balance the oxygen, and we do that by adding water. That's because these are aqueous solutions, so we can add water if we need to balance any of these reactions that have the oxygen in them. Alright, so we've got no oxygens over here, we've got 2 oxygens over here. So in order to balance the waters out, I'm going to have to put 2 waters over on this side. So now I've got 2H2O over here, and I need as many waters added to this side as I have oxygens on this side. So that's 2 oxygens needing 2 waters over here. Down here I've got, let's see, 7 oxygens on this side, no oxygens over here, so I'll need 7 water to balance that one out. Alright, so that's the oxygen handled. Next we want to balance the hydrogens, and we do that by adding H pluses. Down here I've got 2H2O, that's 4 hydrogens. I've got no hydrogens over here, so I'll add 4 H pluses over here to balance the hydrogens out. Remember, we're balancing for acid first, and then we'll balance for base later. Okay, next we've got 7H2O over here, so we've got 14 H pluses. I'll put 14 H pluses over here. Alright, so we've got our hydrogens handled. The next thing we want to do is balance the charges. Now we do that by adding electrons, but before we do that we need to figure out what charges we have on each side. If there's no superscript above the compound, that means you can assume the charge is 0, so water has no charge. Now over here my total charge is going to be 2, and my total positive charge on this side will be 4. So to figure out the number of electrons, what I like to do is find the difference between the charges on each side. In this case it would be 4 minus 2 equals 2. So that's the difference. We've got 2 plus on this side, 4 plus on this side. So the difference is 2. And then add that number of electrons to the side that has the higher charge. So if we've got a total charge of 2 on this side, a total charge of 4 on this side, and my difference is 2, I'm going to add electrons to the side that has a charge of 4. And that's going to balance out my charge. Now, if you don't believe me, take a look. You've got positive 2 on this side. Now, since electrons are negative, that's going to be 4 minus 2, which is 2. So 2 and 2, which means that we've balanced the charge on this reaction. Now, in the other case, we've got a total of 14. That's 14 H pluses. That's going to be 14. Minus 2, which is 12. So we've got a total of 12 on this side. Now here we've got 2 times 3, so that's going to be 6. So the difference is going to be 12 minus 6, which equals 6. So now I know I'm going to have to add 6 electrons to the side that has the higher charge. So I've got 12 on this side, 6 on this side. This side is higher, so I'll put the 6 electrons over here. Double checking, negative 6 plus 14 is 8, minus 2 equals 6. So we've got a total of 6 on this side. 2 times 3 is 6, and that's 0, so we've got 6 and 6, so that balances out. Alright, we've just got a little more to do. Okay, so now we've got our charge balanced reactions. Now we have to be able to multiply these reactions by something to get rid of the electrons. Now I've got 6 down here and 2 up here, so I'll have to multiply this top reaction by 3 so that I can even out these electrons to make them 6 in both. So I'm going to go ahead and do that. So it'll be 3 times 2H2O plus Mn2 plus and the other one I'm just going to keep the same. Right, now what I'm going to do is I'm going to add these reactions together. So the 6 electrons will cancel with the 6 electrons up here. That'll be 3 times 2, so that's handled. Now let's look at the rest of this. That'll be 6H2O plus 3Mn2 plus plus 14H plus Cr2O7 2 minus. That gives 3 MnO2 plus 12H plus 2Cr3 plus 7H2O. So you can see what I've done here is I've multiplied through by 3 on everything at the top, and everything on each side of the arrow is staying on that side of the arrow. And for this one I didn't have to multiply it by anything, so everything's just stayed the same that was in this particular reaction down here. Now we're not done yet. We can actually shorten this because we've got H pluses on both sides, and we also got waters on both sides as well. Now if we've got 14H pluses over here and 12H pluses over here, I can subtract 12H plus from each side, and that will give me 2H plus over here. And I've got 6 waters on this side and 7 on this side, so if I subtract 6 for H2O from each side, then I will be left with just 1 H2O over here. And this is going to turn out to be my reaction that is balanced for acidic conditions. So I'm just going to rewrite it up here. Alright, so there's my my reaction that's been balanced for acidic conditions. Now we're going to just check this out and make sure that it does indeed balance. We've got 6 and 2 is 8, minus 2 equals 6, so we've got a total charge of 6 on this side, total charge of 6 on this side, that's okay. Let's look at the elements. We've got 7 oxygens over here. Here we've got 3 times 2 is 6, plus 1 is 7, that's good. Hydrogens, we've got 2, chromiums 2 and 2, manganese 3 and 3, and it looks like everything's okay. So that's a good thing about redox reactions. You know you're right because everything balances out, including the charges. So that's so it works out good. All right, let's look at our last step here, and that is taking this and turning it into a base catalyzed process, or a base reaction. And by basic conditions, I'm talking about converting the H plus into OH minus. Alright, so how do we do that? Well, what I'll do is I'm going to go ahead and rewrite this a little bit more clearly down here so you can see all the steps. Actually, I'll just cut and paste it. Alright, so we've got plus H2O over here. Now to balance this for basic conditions, what we're sort of doing is titrating the reaction. If we're titrating, we're adding enough OH minuses to eliminate or neutralize the H pluses. So I have 2 H pluses over here. I add as many OH minuses as I have H pluses. So I'm going to add 2 OH minuses over here. and I'll add 2 OH minuses to this side as well. And when I do that, I recognize that by adding H plus to OH minus, I'm going to get water. And if I have 2 H pluses and 2 OH minuses, I'm going to get 2 waters. This is because 1 H plus 1 OH minus gives water. So if I have 2 of them, 2 of each of these, I'm going to get 2 waters out of that. Alright, so now I can go ahead and do that. That was the entire point of adding the base, was to neutralize the H plus. Let's see. But now we've got 2 waters on this side and 1 on this side. So I'm going to subtract 1 water from each side, and I'll be left with 1 water over here. So my final reaction balance for base will look like this. And I can check this and make sure that the charges do indeed balance and everything else balances. I've got 3 times 2 minus 2, that's a total of 4 on this side. I've got 3 times 2 minus 2, that's 4 as well. Oxygens, I've got 1 and 7 is 8. I've got 2 times 3 is 6 plus 2 is 8. I've got 2 hydrogens here, 2 hydrogens here, 2 chromiums here, 2 chromiums here, 3 manganese, 3 manganese. Everything balances out, so we know that we're right on this one. What you'll notice is that I'd say probably 90% of the time when you balance for base, it's almost like the H plus disappears, goes over to the other side and becomes OH minus. So you have as many OH minuses on the other side as you have H pluses. And it looks like the water flips sides as well. So you get H2O, that goes over here and that becomes H2O. It doesn't happen all the time, but it's a good little pattern. It can help you out sometimes. Alright, so just summarizing the steps. We split it into half reactions. We balance the oxygen. We balance the atoms that were being oxidized or reduced. In this case it was manganese and chromium. Then we balance the oxygens by adding water. Balance the hydrogens by adding H+. We balance the charge by adding electrons. We multiplied the half reactions to make the electrons the same. We added them together, cancelled the electrons, got our reaction, then we balanced it for base.